So welcome once again for the next module. As far as number systems are concerned, we have covered all the topics except the last topic and the most important topic, that is called as rationalization of the denominator. In mathematics, it is a convention that the denominator should be always rational. There is no hard and fast rule, but there is a convention. Convention means for our convenience, we put some rules for that. So, the denominator of a number, it can be a fraction or something of that sort, it should be always rational. Sometimes we come across a situation where the denominator is not rational. If it is not rational, so we have to make it rational. This particular process is known as rationalizing the denominator. Now the denominator can be a monomial, it can be a binomial. So we got certain rules for that actually. Not exactly rules, but a method of rationalizing the denominator. First we'll just take simple examples and I'll just let you know how to rationalize the denominator. Say for example, I'm having a quantity, say 5 upon root 3. Now here 5 is rational, but the denominator root 3 is an irrational number. You have to find a number. If I multiply that number with the denominator should be rationalized. So the first thing which comes into our mind is root 3 into root 3 is 3, which is rational. So if I multiply the denominator as well as the numerator by the same number, the value of the fraction does not change, right? इसीलिए हम क्या करते हैं? We multiply the numerator and denominator by root 3. Since we are multiplying the numerator and denominator by the same number, the fraction remains the same. And in doing so, what I am getting is the numerator will be 5 into root 3, that is 5 root 3, and the denominator root 3 into root 3 is 3. In the process, the denominator has been rationalized without compromising the value of the fraction, because हमने एक ही नंबर से न्यूमरेटर को भी और डिनोमिनेटर को भी मल्टीप्लाई किया है, राइट? सो जिस नंबर से मल्टीप्लाई करने से ये rationalize हो गया है, this number is known as rationalizing factor. तो यहाँ पे root 3 is the rationalizing factor. अभी हमारे पास एक डाउट आएगा, क्या सिर्फ root 3 ही rationalizing factor है? No, we can have infinite number of rationalizing factors. So for example, if I multiply the numerator and denominator by say root 27, right? So the numerator becomes 5 root 27 upon root 3 into root 27 is root 81, and root 81 is 9, right? So this is also rational. अभी आपके दिमाग में आएगा कि क्या ये नंबर और ये नंबर सेम है कि नहीं है, right? They are actually same. If I simplify this one, I will be getting the same answer as 5 root 3 upon 3. जैसे I can write this 5 27. Root 27 can be written as root of 9 threes are, and here we got a 9. Square root of 9 is 3. So 3 5s are 15 root 3 upon 9. So 3 5s are and 3 3s are. So this is 5 root 3 upon 3, which is same as this one. So कोई भी irrational number का एक ही rationalizing factor नहीं होता है. We can have infinite number of rationalizing factor. तो उसमें सबसे छोटा वाला जो रहता है, we take that one because calculation becomes easy. There is no hard and fast rule. Calculation becomes easy. And for that reason, we have this rationalizing factor as root 3. We'll take one more example. Say we are having something like 5 plus root 2 upon 3 root 5 से ऐसा कुछ है. Now here the denominator is 3 multiplied by root 5, although 3 is rational, but this whole denominator 3 root 5 is irrational because it is having an irrational factor as root 5. So I can multiply the numerator and denominator by 3 root 5. But 3, since it is a rational number, no need to take this one. Even if I multiply it by 3 root 5 and 3 root 5, there is no change. You will get the same answer. But suppose you 3 root 5 से multiply करूँगा, it becomes a very big complicated solution. So what we will do is that we will only just pick up the irrational part and we'll multiply the numerator and denominator by the rationalizing factor. So root 5 का rationalizing factor is once again root 5. So we'll multiply the numerator as well as the denominator by root 5. Now the numerator becomes, this is root 5 multiplied by this bracket. So root 5 into 5 is 5 root 5 plus root 2 into root 5 is root 10 upon 3 root 5 multiplied by root 5. The irrational part will multiply irrational part. Can I write this root 5 as 1 root 5? There is no change. So root 5 into root 5 is 5. 3 into 1 is 3. So 3 5s are 15. Okay, rational. Right? So to rationalize the denominator, we need to find a rationalizing factor and then we multiply the numerator and denominator by that rationalizing factor, जिसकी वजह से ये rational हो जाता है. Right? We'll take one more example. So 6 plus 3 root 5 upon root or 3 root 7 say. Now the only irrational part of the denominator is root 7. 3 is already rational. So no need to multiply by numerator and denominator by 3 root 7. We can simply take the irrational part and multiply the numerator and denominator by the rationalizing factor. Here in this case it is root 7. So the numerator becomes root 7 multiplied by this bracket. So root 7 into 6 is 6 root 7 plus root 5 into root 7. The irrational part will multiply with the irrational part. So root 7 into root 7, root 5 into root 7 is root 35. So this will be 3 root 35 upon. Now see the denominator. Irrational will multiply irrational. So root 7 into root 7, 7. 3s are 21. Now I can further simplify this because 6 and 3 may be got a common factor 3. So I can take 3 common. Here I am taking 3 common because 3 can be reduced with 21. So 3 into 2 root 7 plus root 35 upon 21. So 3 1s are and 3 7s are. So it will be 2 root 7 plus root 35 upon 7. Get it? So this is how we rationalize the denominator if the denominator is a monomial. So 3 root 7 is a monomial. Now we may come across a situation where the denominator is not rational as, no, it is irrational only, but suppose थोड़ा सा complicated ले लेंगे हम, not complicated, अलग type का question. So 3 plus 2 root 5 divided by root 28. Now दिमाग में हमारा आता है कि यार since the denominator is root 28, we'll multiply numerator and denominator by root 28. But suppose मैं इसको simplify करूँ, denominator को मैं simplify करूँ, तो उसमें मैं rational part और irrational part अलग अलग कर सकता हूँ मैं, है ना? So root 28 को हम लिख सकते हैं root of 4 into 7. तो square root of 4 is 2, so 2 root 7. So the root 28 is nothing but it is 2 root 7. So can I replace this root 28 by 2 root 7? Now it has become simple. I can multiply the numerator and denominator by root 7. Getting a point? And the usual procedure. इसके पहले जैसे हमने किया था वैसे ही करना है. Now the other type, that is if the denominator is not a monomial. अगर वो monomial नहीं हुआ तो binomial होगा, trinomial होगा, but हमारे syllabus में till binomial only we are having. But I would like you to try one trinomial also after completing this binomial, right? Say 3 plus root 2 upon root 3 plus 2. Now earlier we had only a monomial, है ना? तो उसको rationalize करना is very simple. Just find the rationalizing factor, multiply the numerator and denominator by the rationalizing factor. But since now the new type में the denominator is a binomial, right? और binomial को rationalize करना is still simpler because यहाँ पे हमको बहुत सारे rationalizing factor नहीं मिलेगा, एक ही rationalizing factor रहेगा which is called as a conjugate. Now what do you mean by conjugate? Suppose if I am having a and b as two real numbers, a और b कौन है? Real numbers हैं, and if they are separated by either plus or minus, say a plus b. So a plus b का conjugate will be a minus b, right? The terms remain same. अगर प्लस रहेगा तो माइनस, अगर इधर माइनस होता तो this will have been plus, right? So these are called as conjugate. Now why should we study about conjugates is that if I multiply the conjugates, that is a plus b into a minus b, so we know that this is an identity which we have studied in the 8th standard. So a plus b into a minus b is a square minus b square, है ना बेटा? So we'll multiply and square of an irrational number here whose order is 2, तो उसका स्क्वायर जो है स्क्वायर रूट ऑफ 3 का स्क्वायर, तो स्क्वायर एंड स्क्वायर रूट कैंसिल, 3 हो जाएगा, रूट 3 इज 3, तो विल मेक यूज ऑफ दैट वन. नाउ हियर a की जगह पे रूट 3 है और b की जगह पे 2 है, so this is in the form of a plus b. So what will be the conjugate of this one? It will be a minus b. So we'll multiply the numerator as well as the denominator by the conjugate of the denominator. So the conjugate of the denominator will be root 3 minus 2 and denominator also root 3 minus 2. Alright. Now the numerator is a multiplication of two binomials. So this is something like 3 multiplied by this bracket, that is root 3 minus 2 plus root 2 into root 3 minus 2 upon, and as far as the denominator is concerned, it is in the form of a plus b into a minus b, and that will be a square minus b square, that is root 3 square minus 2 square. Now how to simplify the numerator? Here this bracket is being multiplied by 3, so each term of the bracket will be multiplied by 3. So 3 into root 3 is 3 root 3 minus 3 2s are 6 plus root 2 into root 3 is root 6 plus into minus is minus 2 root 2 upon root 3 square. So root 3 का square मतलब root 3 into root 3, root 3 into root 3 is root 9 and root 9 is 3. So ये सब करने के बजाय root 3 into root 3, 3 minus 2 into 2 is 4. So 3 minus 4, that comes out to be minus 1. So this, the denominator has been rationalized without changing the value of this one, right? So ये जो है binomial को rationalize करना है तो उसके conjugate से multiply and divide करना है. We'll take one more example. Now ये numericals करते समय we have done certain things like a square minus b square, how to multiply two binomials, है ना, इस टाइप में. तो आपके एक्सरसाइज में ऐसे क्वेश्चन आएगा कि what is 3 plus root 5 multiplied by 5 plus root 6, something of this sort, right? So whatever algebraic rules we are following for all rational numbers or irrational numbers, for that matter real numbers, will be used here. Now say for example we are having one more 2 root 3 plus 4 root 5 upon 3 root 2 minus 5 root 3. Say for example, ऐसा कोई तो भी एक क्वेश्चन दिया हुआ है and we are supposed to rationalize the denominator. We have to rationalize the denominator. तो इसको rationalize करने के लिए क्या करना पड़ेगा? The denominator is in the form of a minus b. तो इसका conjugate will be a plus b. So we'll write a statement multiplying the numerator and denominator by the conjugate, that is 3 root 2 plus 5 root 3 upon 3 root 2 plus 5 root 3. Now the numerator is a multiplication of two binomials, है ना? So this term into this term. अब यहाँ थोड़ा ध्यान से देखना, मैंने जानबूझ के ऐसे टर्म्स लिए जहाँ पे आपको कैलकुलेशन विल बी थोड़ा सा कॉम्प्लिकेटेड रहेगा. You'll find that you'll have to multiply the rational with the rational and irrational with the irrational. So ये step मैं थोड़ा सा deeply कर रहा हूँ. 2 root 3 multiplying this bracket, that is 3 root 2 plus 5 root 3 plus 4 root 5 multiplied by the same bracket, that is 3 root 2 plus 5 root 3 upon, now the denominator is very easy actually, you know. This is, the terms are same, a minus b into a plus b is a square minus b square, that is 3 root 2 square minus 5 root 3 and its square, right? Now the numerator, this monomial is multiplying this binomial, so the rational will multiply the rational. 2 multiply 3, 6. Root 3 into root 2 is root 6. Then 2 5s are 10. Root 3 into 3 is 3. Alright? Plus 4 3s are 12. Root 5 into root 2 is root 10. Plus 4 5s are 20. Root 5 into root 3 is root 15. Upon, now this is very important, 3 root 2 square. So 3 ka square multiplied by root 2 ka square. 3 ka square is 9. Root 2 ka square is 2. So 9 2s are 18. So the square of 3 root 2 is 18 because 3 ka square is 9. Root 2 ka square is 2. So 2 into 9 is 18 minus 5 square is 25. Root 3 square is 3. So 25 3s are 75. Now you have to just see the numerator. 10 3s are 30. I can write it here. And all of them are unlike terms. So we cannot add them. So 18 minus 75. 75 minus 18. 15 minus 87. 6 minus 1 is 5. 57. So with minus sign. So this will be minus 57. This is how we can rationalize the denominator if it is a binomial. Alright. Now this ends this chapter, that is number system, and some laws of exponential laws are there which already we have done in 8th standard, right? So textbook mein diya hua hai, you just go through that rules, that is a raised to m into a raised to n is a raised to m plus n. I would like to suggest you people is that when we were doing this chapter in different modules, right? So after completing the module pura, all the modules, you just go through the textbook and you start with the introduction part, right? Now here, introduction part में आपको ये समझ में आएगा कि what are actually real numbers and what are the operations on real numbers and where we actually use these real numbers, right? Because मैंने आपको एक specifically exam point of view से, exercise point of view से मैंने आपको पढ़ा दिया है, right? अभी आपको जो है थोड़ा सा उस idea को expand करना है कि where exactly we use these real numbers, है ना? So what are the actual operations on real numbers, right? So this ends this chapter, that is number system. From the next module, we'll be taking a new chapter, right? Most probably, एक geometry का chapter करेंगे. Mostly, I'll see triangles or something of that sort. But this is the last module as far as this chapter is concerned, right? Till we meet, goodbye.